Yeah, thank you for the introduction. So, yeah, just continuing about myself a little bit. So, I was indeed working for embedded development for quite a long time, doing some networking stuff, working on this kind of different devices and interesting low-level stuff. I'm currently just at CLion team and JetBrains. So I do product marketing management, I do some evangelism, I run my own user group in St. Petersburg in Russia for C++. So pretty much lots of things happening in my life for now. So, but today I'm not going to talk explicitly about the CLion, so I'm mostly going to cover the whole ecosystem for code quality tools for C++. I will be mentioning our tools just naturally because they are like happily the part of the ecosystem, but if you would like to strategically learn more about our tools, I welcome you to our booth. So just come there and we'll show you all the demos. He'll be just mentioning some of our tools. And I will take to keep it more general, not the marketing talk for sure. So I'm going to start with a quote from Bjorn, actually the very famous one, that C makes it easy to shoot yourself in the foot, C++ makes it harder, but when you do, it blows your whole leg off. And there's a very nice page on Bjorn's site, which is called Really Say That, and that's the first quote in the list. He really confirms that he said that, but which is more important, there is a comment actually about the quote, and he said that he thinks that that's actually true for all powerful languages. So because when you get more power, you can get into harder problems, because like the easiest one to solve somehow, but the harder you get, the further you get, the harder problems you actually can meet. But I definitely think that with C++, we have some specific that really makes it hard for us sometimes to use it. And if we try to put all the specific in the list, I think we get something like that. So the first part is that we still have C and C++. So we are not always alone with C++. We always had C. That's some kind of a heritage we have. That's some kind of a background that we have. And quite often there is a mix, and quite often people are like writing code in C++ and think they are writing code in C, and the opposite, they're writing code in C and think they write code in C++. There are dozens of threads around Stack Overflow asking questions like, what are the features that works for C and is not available in C++ and vice versa? And it's still surprising that people keep asking these questions still. So there are a lot of active threads on those. So they are still discussing these designated initializers or compound literals or whatever, like these type generic macros, instead of like using function overloads. So there are many things like that happening. And because of C and C++ compatibility, there are quite often a mix of languages in one project. And you're not always like coming to some kind of a mixed language project instead of just a pure C++. I'm not saying that's good or bad, but that's just a point we always have to keep in mind. And the other part is that we have legacy code that is sometimes in C, sometimes in old C++. We have code with some kind of a modern C++ features that we have in the standard. And we have like various technical specifications, features that are not yet available in the standard and even not yet available in all the compilers, but the people are already using them. And they are like coming to the tool vendors, asking for support, mixing all these features in one project, and doing lots of stuff like that. There are no good solutions for these kind of problems for now. There are some very interesting initiative from Google announced at CPPCon this year that's called the AppSol library, the libraries that help you to migrate to the newest standard in some smoother way. But still, the problems quite often come out of that fact. And if we look at how the C++ evolves nowadays, there are two completely different opinions. Some people are saying it's evolving quite quickly. Some people are just pretty much sure that it's evolving too slow. And so like both people are like working sometimes on the same project and dealing with the same C++ actually that we have for now. And some kind of a trend of the modern C++ is more functional and mathematical concept in the language. It makes the language harder for both groups actually, for those who are starting with the language and for those who actually knew the language for 30 years already, getting completely new language. And the tools problem is actually quite actual here. So the tools are missing in the ecosystem for many parts, and unfortunately that's the story that we have. So time for a story. I like telling stories in my talks. So talking about the code quality. I was working in the team. We were doing the like some kind of controller for the user's policy in 4G LTE networks in quite a big operator in Russia. And the team was very nice. We had a very nice code. It was like solving dozens of different problems, working for thousands of users. And it was in C++ with some piece of like bash scripts, Lua, and some more stuff. But actually, when someone from the core team was leaving the team, we had to aggressively rewrite his code. His or her, actually. And that was a problem. So we were not passing this kind of the famous bus test. So we had to throw away the code. And that was because it was easier for us to re-implement it than to support it. And for me, that's actually the bad thing. So that means that the code was bad. Let's look at some other angle and take a look at some other story. This is the go to fail story. I think many people here have heard about it. So just in a nutshell, so once Apple issued an update for iOS, which had a very nice release notes actually. It was written like the impact. An attacker with a privileged network position may capture or modify data in sessions protected by SSL. Wow, that's a huge break, you know? Like, because SSL, that's indeed for security, for protecting your data. So what actually happened? Since the code happened to be open source for the history, the developers found this kind of lines there, the doubled go to fail line. There were lots of discussions. Some were blaming old-style go-to statements. Some were just saying that we have to change the error handling idiom. There were people who were saying, like, just the indent is improper. You have to use the proper formatting tool. Some were saying that you have to run the code analysis, because if you just turn on the warning on Clang, you'll get the unreachable code. And some have to say that, like, on code review, you can catch this kind of problems, whatever. So there are like dozens of ways to catch the problem, but still it happened. It was in the production. They caught the bug happily. They issued an update. Everything is fine. Hopefully nothing was destroyed by the problem, but still we have a nice story now. Another example, let's move to C++, because that was about the C. What about the C++? We got used that C++ always have explicit types. We always know the type because it's always written in our code. But do we know? In this code, I don't have types at all. And the operation result, its type is just deduced from the code that I have. So to understand that it's actually a double value, I just have to look at the usage to see that the do operation is using the double value, and that's why it's double. And I infer this in my head, and that's what the tools have to do to understand the type. But that actually shows that currently the C++ is kind of tricky. It doesn't show us even the type information. You could completely skip it out of your code. And talking about heritage and C and all the stuff that we had there, we had macros and we have includes, and we have all this preprocessor history. And with the preprocessor, you could actually come to a very creepy code like that. Because depending on the magic value, you either have x as type or x as integer. And that means if you take a look at the last line of the test function, these x angle brackets, this is either a template or an expression. And to know that, you have to understand if x is a type or not. And to know that, you need to know the magic value, because it could be both. And this is a good compilable code that you could write. Okay, so that's the kind of a list of examples that could scare us sometimes with C++. And since we're going to talk about the code quality tools, let's see what is actually the code quality. There are a couple of famous definitions. Some of them say that code quality is the ability to read, to maintain, to use the code, and it should work correctly. That's fine, good definition. There is also a very famous consortium for IT software quality that issued these 5 words as a definition for the code quality. Reliability means the likelihood of potential application failures. Efficiency means the efficiency in terms of performance or any other resources, like people resources, the team resources, or whichever resources you want. Security is the likelihood of potential security breaches, like this go-to-fail error. Maintainability, it means how easy you can adapt, port the code, and for C++, it's actually quite important thing, how easy you can port the thing to another platform, how you can transfer, enlarge the functionality, add new features, and the size is some kind of a measurement for this copy-paste effect and run functions, like very long functions, redundant code, and other things. But I actually like this definition for the code quality much more. That's the only real definition that is actually happening in our development life. And the picture is about code review, but I guess it happens for any process in your development. Like either it's like maintaining, adding new features, or maintaining some old code, or reviewing the code, or testing the code. That's the only valid measurement of the code quality. Code is either good as on the left or bad as on the right. That's it. Okay, we have the definition for the code quality. Let's start with the tools. And I'm actually quite surprised that we're coming in the C++ community to the thought that we need tools only now, after 30 years. And Björn started this kind of we need tools slogan 2 years ago at CPPCon, 2050. So we have a language for that very long, and we just started to think about tools. But like, good that we started. But like, why do we need them? And the answer here is that we can create any kind of good guidelines that Björn was presenting in 2015, any kind of good styles, whatever. But if the tool is not forcing these guidelines, not throwing them into our face, we won't follow them. Because we might remember about the guidelines for 10 minutes when we started our coding during in the beginning of the day. But when the deadline that happened yesterday came into the room, the manager joins, some new team members joins, some other team members are just leaving the team, and with all this hell, we just started forgetting about all the guidelines that we have. So if we don't have tools that are forcing us to follow the guidelines, we won't follow them. I believe there are some people that still will do. They're like crazy and brilliant, but I guess, unfortunately, most of us can't keep all these things in mind. So if we talk about the tools for the code quality, I strongly believe we can divide them into these kind of groups. And we'll go through these groups one by one and look at the tools that we have in each group. So we'll start with the code style and formatter. And here I mean like all these tools that help us to indent the code, to put the proper spaces, put the proper brackets, like to format some generated tags, some boilerplates, templates, and some style things like some naming conversions are also falling into this group. If we talk about C++ specific and formatting tools, I suggest we look at this kind of example. And what we see here is the test function that has two lines in the end, one with X and one with Y. They're looking very similar in terms of just the syntax, but they're completely different. Because the first one is a C style cast, and the second one is an expression. Because like X is a type, and Y isn't just an integer. And if we occasionally get a style guide that suggests us to format this kind of two situations differently, then we have to do something like that. So we have to put spaces in different places, in the first and in the second example. And what that means for the tool that is actually doing the formatting, that means that the tool is not allowed just to work with the syntax. It has to know the semantic of your code. It has to understand if you're writing a type or not in C++. And that's the major point for all C++-based tools. OK, so the first point for formatter tools, it has to do some kind of a parsing, resolving at least to some extent to format the code properly. What else we have in the C++ ecosystem? The thing for us is that we have a variety of standards. We have like this LVM, LDB, GNU style, Google style, Chromium style, whatever. Each company sometimes has its own style for C++ code. And the problem is that not that we have that many. Like some languages just have a couple or some standard that is used like for Swift or Objective-C when most of the companies are using just Apple style. But the problem is that these styles sometimes are not compatible. That means they are about different things, so you can't just easily convert one into another because they're covering different aspects. Okay, and another good question for formatting is actually when to reformat. You can reformat on file save, that's very easy. You can reformat on the fly while typing, and that's what most of the IDEs are actually doing, trying to reformat your code while you're typing. You can reformat on as a pre-commit hook, and that's how the Clang format is quite widely used in various tools, just configured for the pre-commit hook or for the file save. And there could be some like explicit actions that you can call and ask the tool to reformat. There's actually one very good point for IDEs and on-the-fly formatting. So why I think the on-the-fly formatting is good, because you always see how the code will be looking like in the end. So you just write in the code style, you just got used to it, and everything is fine. The tool is just reformatting for you on the fly. And the tools like IDEs, they usually have some kind of language engine, some parser that does the job, and so they know is it a type or not to reformat properly. But there still could be issues. There could be issues with the performance, because reformatting on the fly means that you have actually to reformat the code somehow when the code is not correct. Because you are typing, and you don't want your code like to jump through your whole screen while you're typing. So there are like different ways to solve the problem, and they could be somehow performance critical. So the tool that I would like to mention here is for sure the Clang format, which is a very nice tool that's a part of Clang family. It's a command line tool that you could like integrate into many tools. Actually, there is like a very nice Vim integration that helps you to. There is a shortcut that you can get, and there is like on save reformat hook. And the nice thing that is when you select some region, it's actually extended to the next bigger synthetic entry and reformat it. So if you just forget to add a couple of symbols to selection, you're safe. There's this very nice like Clang format off-on commands, so that you can turn off the formatting over any particular region. And the thing that I really like and appreciate about Clang format is library profiles. That means that if you have a library that have a style different from the style of your code, you can put a special Clang format options into this library. And some like good library providers, they even put it into the version control along with the library. And so the Clang format is smart enough to reformat the library with the options that it finds in the library, and your project with the options that are like placed in your project. So you can have two different styles with the like single run of the tool. And so it's integrated in like many famous tools nowadays, but it has one but here in this list. And the list is actually that being a part of the LLVM family, Clang format is not using a Clang parser. It's using some kind of a fuzzy parser. It's done actually to increase the performance, because Clang format is extremely quick, but because it's not actually properly parsing the code. And the problem is that it doesn't even go into the header files. That means that you can actually confuse it quite easily. But that's the choice you make, actually. You either get a very quick tool that is integrated everywhere, or you just want to have it, want it to format all your tricky C++ that you might have properly. As I said, the IDEs are mostly using some kind of a built-in formatter tools, and the things that they are suffering from is mostly the conversion of the formats, because each IDE sometimes quite often actually uses its own format, and they're not convertible between each other, and all the people start asking about the Clang format options and how to convert the Clang format into the IDE's formats and back. And all these questions are still a problem, because as I said, sometimes the styles are not convertible easily because they are covering different set of settings. And the tool that I would like to mention here is a very nice tool that we've implemented in the hackathon project and that I really like. So it was some kind of not part of our job, but just we did that for fun. We call it style extractor, and it actually extracts the style from the code formatted properly with the style guidelines. So if you just took a bunch of code, formatted properly, run through this tool, you get as an output all the settings to format your code. And this tool was like, it's used some genetic algorithm with some optimizations. And with the help of this tool, actually, in CLion, we managed to get Google and GNU styles on board, like the predefined styles that the CLion is using. They were extracted in that way. OK, if we move to the next group. Yeah?
Quick question. In
Sure.
CLion, is that installed by default?
So the question was if the tool is installed in CLion by default. Since that was just a hackathon project, it's not. We're thinking about moving to the production, but still, it was some kind of a toy. So maybe it will appear in the tool.
Is it publicly available?
The tool, like the question was about publicly availability. It's not, just because it's some kind of an internal toy project. We hope to move it to the production, hopefully soon when we have some time, but still not.
Sorry to interrupt.
Yeah.
So in CLion, is there a way of doing code format checking by default?
So the question was about code formatting in CLion. So actually, in a nutshell, the code formatting in CLion works in the following way. We have predefined styles. The Google one is used by default. So you can select any of the predefined styles and then configure a whole bunch of settings on top of that just to tune it to your favorite code style. OK, moving to the next group, that is generate the code. So talking about code generation, actually, there's a good question why to generate the code. And the answer here is that first it's to save the time, that's obvious. Keep to style guidelines, because that's a good way to push you to some style guidelines that generate the templates code that following these guidelines. So use some common design patterns and to avoid errors. So you could generate file templates, for example, with if-def guards or pragma guards or whatever. You can generate some commands, for example, and to fill them later in some kind of a Doxygen style to get the documentation for your code. You can generate some code snippets. And actually, nowadays, IDEs support quite a lot of code generation, be it the class or the file generation or getters and setters or some constructors and destructors, and some more profound stuff like we have, for example, operators generation or an option to generate swap or hash operator in Resharper C++. So what I want to show you here is this kind of a long list of lines. And I will run a kind of a demo here. So what I'm going to do here is I just typed manually only the 2 lines at the very top. Like in this distance class, I just added these kind of private members, like fit and inchers. And all the rest, I'm going to actually generate automatically. So that's what a tool can do for you. It can just simply generate all the default stuff, like all the constructor or the getters and setters, or some kind of an operators, and you can add some options like to use std to generate in place, whatever other options you prefer, like some stream output operator like here. Yeah, so that's it. And if we are back to the to this slide, so you can see all this code was actually auto-generated, and that's what a tool can do for you. You can save your time by generating these kind of things. But OK, so we generated the code. There are more tools that can generate code. That's actually some kind of a specialized tools like Readable that helps you to serialize data to provide you with some careful reading, writing operations, hiding some implementation details. There are some Coq tools that people are still using, this kind of a transformation tool. There are some Clang-based tools, surprisingly not that many of them, but the Clang has an access to AST. That means that if you have a syntax tree, you can generate a lot of things on top of it. But surprisingly, I don't see that many projects, at least available on GitHub, around Clang-based tools for code generation. But what I'm really happy to see nowadays is the Metaclass. Metaclasses proposal by Herb Sutter is really a next step to the code generation. Because the first step was just to use a tool to generate all these boilerplates, templates for you in your IDE or in your editor. But the Metaclasses is actually a much better step. it's like an attempt to tell compiler, generate it for me in some kind of a general way, in the way that you can describe and you can share. It could be a library, it could be a standard library, and you can avoid the boilerplate code. You can add some DSL to your language, you can add some extra types, and that's actually the example from the Herbst proposal. So you get some kind of a code for shape. You get some Metaclass that is on the left. That's just the code that the compiler is using to generate this kind of an output. So you can generate some, like add some methods, say that they are private or public, virtual or non-virtual, to add some default values, to add some like more methods to your class. And that's actually a good thing, because you're not relying even on a tool, you're just relying on a basic compiler. And if this is a part of a standard library, you're just relying on the part that everyone around you is also relying to, so you don't need to think about the compatibility, because it's compatible. Standard library, like in an ideal world, mostly compatible. Like, this is a good step forward, and hopefully once we have it, we could just avoid many kind of generators in the tools. But what we definitely have to get here is some kind of a tool support again, but the tool support will be different. Previously, the tools were generating some code for me, but now the tools have to help me to understand what I actually gonna get in the end. Because this code on the bottom, that's what I actually get after the compilation. But I would like to know that before I even compile the code. So on this step that is on the top. And to know that, I need an ability to ask the tool, please show me what's going to be in the end. And the tool has to show me this part of code. And so this kind of interpretation that the tool has made, has to show me the output, this kind of auto-generated code. So, okay, that was about the code generation. Maybe the part that is most widely associated with the code quality is the code analysis. The code analysis can be divided into two groups, static and dynamic tools. And if we start with the static tools, so it's in turn can be divided into two groups, compiler warnings and the things that are not checked by the compiler, like some data flow analysis or some other extra checks that the compiler is not capable of. And luckily, we have lots of tools in this field for at least some kind of an old C and some kind of a modern C. Some tools are also appearing. So if we start with kind of an old tool, we have CPP check that is existing for 10 years already. So it's surprisingly appeared in 2007, so it's like really 10 years ago. And it's still active. The latest release was in July of this year, so it's still under development. It actually gets around 170 checks, not that many, but checks more or less general things like out-of-bound index or memory leaks or mismatching allocation, deallocation, or incorrect size of arguments, like, for example, when you pass the negative, obvious negative there, and some checking for variable scope and some exception safety. And since the tool is for 10 years already with us, it has integration into many IDEs, so it's kind of used widely. The problem with it is that since it started long in the past and it's not developed that actively now, it doesn't support the modern C++ in a very good way. So it's more for the old style code. But what can help us here is a Clang analyzer, which is like a part of the Clang ecosystem. So if you just get a compiler, you get a Clang analyzer, because that's just a part of a Clang compiler. You just have to run the Clang compiler with minus analyze options and to pass the list of checks, or just to ask for all the checks. And the Clang analyzer, so it has some basic checks for C and C++, so around 40 of them. And it has checks for not only C++, but for C and Objective-C if you need them as well. And currently, the Clang analyzer is available as a part of another tool from the Clang family, which is Clang-tidy. And the Clang-tidy is actually much more than the Clang analyzer. So Clang analyzer is just one part of checks that Clang-tidy is capable of. Clang-tidy is more than 200 checks, and maybe the most valuable group of checks is modernized group that helps you to transform your code from the old C++ to the new C++. And so, like, for example, to change like old style C header file includes that you used in the code to like more and modern C++ ones and other tools, like other cases. So like Clang-rename is very nice and huge, and it's currently started coming to many IDEs. Like there is Eclipse plugin, there is NetBeans plugin, there is Visual Studio plugin, and this is just a demo from CLion. So this is just the Clang-rename completely running on this code. So you can achieve the same just running the Clang-rename from the command line and using the -fix option to apply the quick fixes. So it can fix this kind of std bind story and all the rest. So that's just the modernized groups of checks running on this piece of code. If we come more to the deeper code analysis, so there's actually the C++ Core Guidelines initiative started by the Björn and the other group of the great people there. So if we're talking about the tool support for the C++ Core Guidelines, so the kind of a support is started in Clang-rename. It's about 16 checks. There are some support like for Clang-rename in tools like Eclipse, CLion, or NetBeans, but there is also native support for C++ Core Guidelines, like in Visual Studio. That's a C++ core checks that they have implemented from scratch, and Cvelop tool has some kind of native implementation for some C++ Core Guidelines checks as well. And I have to mention the tool named Cavirity here, because that's a tool that's kind of widely used in big companies, mostly because it has a very good integration into CI, that is continuous integration. Because for big companies, sometimes the flow is different. So no one in the development team is just running the code analysis on their like local machines. They just push the code somewhere to the server. On the server, it's like compiled, tested, and the code analysis is run on it, and just the reports are coming back to the developer, and it's fixing some problems. So the Cavirity is some kind of a tool for that, and it has this kind of a nice integration. And I know many companies who are actually using Cavirity for this kind of business process support. There are more tools, like there's PVS Studio that's quite famous, Infor tool that I like mostly because it's some kind of a tool based on idea of the formal verification of the software. That's the tool from the Facebook. And there are like dozens of IDE checks that the IDEs do on their own language engine. And for example here, and if we talk about the checks that are not implemented in the compiler, it could be data flow analysis, and that's the checks that we run into that we have in CLion, when you can check some kind of the things that you never can catch with the compiler, like this condition is always true on the left or unreachable code on the right. So to understand this, for example, if we take the example on the right, to understand this, you have to get through your code to understand that you are assigning only red, blue, or green color in the first case, switch case statement to the C variable. And so you never get it like color yellow at this point when the checks is showing the warning. And this kind of the checks are not implemented in a compiler for sure, because it's how the data flows through your code. If we talk about the dynamic analysis, so there are actually quite a lot of tools, but I would like to talk about two groups and two big representatives of each group. And this group is, one group is for Valgrind and one group is for Google Sanitizers. And the story is here is that they are completely different in many aspects. So the main aspect here is that Valgrind is running your program, your app, on a virtual machine. And so that means that it doesn't require any kind of free compilation. So it just takes your code. Doesn't matter which compiler you were using for recompiling the code. It even doesn't matter actually which language it was. It supports many, many languages. And it just runs it on a virtual machine, which comes to the fact that it's quite slow. It's for like 20 to 50 slowdown for the Valgrind. But it supports lots of platforms. It supports lots of compilers, and it's actually quite easy to start. You just get an executable and run it under Valgrind. You don't need anything else. And with Sanitizers, the story is different because it actually requires the recompilation, and that means that it comes with the compiler support. So it's supported in Clang from version 3.2, 3.1, and 3.2 for some parts of the Sanitizers, and GCC from only 4.8. But the slowdown is much less, so actually nearly 10 times less, and this is a good point. But there is some kind of a limitation in terms of not only the compilers, but also the number of platforms that are supported, and so on and so forth. And also the big difference is here that Valgrind is actually running one thread at a time. That's like, again, about the slowdown. And the Sanitizers is actually running at speed, so that's much quicker. The good thing is that actually Valgrind, that is a tool that is mostly likely known as a memory check, but it's much more than a memory check. It's actually can check, like, first of all, yeah, it has the memory check. That's the one option. And it can check many things like initialized memory or like some memory leaks or whatever. And this is kind of the things, kind of an output that you can get. So that's not the command line output, that's an integration into CLion output, but the story is nearly the same. So you get the stack that you can see on the left for the leak, and you get some reference to the real code, like the line number that in the IDE we can convert to the real code representation, so you can just quickly jump there. So you just run your executable on the Valgrind memory check, and you get some results there. But there is also a cache-grind, that is a cache profiler. There are some accuracy points because that's a simulation of your program on a virtual machine. That means that it doesn't take into consideration any kind of kernel or operation system shadowing done by the operation system or kind of external processes that can interfere. But still, you can get some kind of an approximation for the cache usages. There is also a call grind, and it just records the call history of your program and presents the result to you. There is some kind of a tricky part concerning the recursive calls, because the cost of the function is actually measured in number of CPU instructions. So for recursive calls, there are some settings to tune. So either to ignore the recursive call or to ignore it, but after some level of recursion. All this is kind of configurable. And there's a very nice viewing tool that's called K-cache-grind, that's just an UI representation of what the call grind actually provides. There is more. There is Valgrind for threads. They're massive for as a heap profiler. And the real Valgrind is very nice because that's actually a very big family of tools under the hood, not just a memory checker. If we talk about the Sanitizers, they are not achieving that many aspects of the profiling or the dynamic analysis, but still they have for sure this address sanitizer. That's the main tool for checking all these out of bounds exception and use after free return or out of scope things. And this is the terminal output. It looks actually nearly the same as the terminal output for the Valgrind, so it has the same idea. It has the stack, it has the reference to the actual code, so you can get some information out of it. There is thread sanitizer available to check the data races when the two threads access the same variable concurrently, and one of it is right. And so you can check this kind of situations with the thread sanitizer. And actually, this option that you see here, that is -f sanitize, that's the option you have to pass to the compiler to recompile your application, because as you remember, for sanitizers, you have to recompile it. So there is memory sanitizer that do some initialized memory checks. And there is a nice undefined behavior sanitizers, because C++ is quite complicated. C++ compiler plays a safe game trying to actually say, this is the undefined behavior. I don't want to just know something about it. That's just undefined. And it would be good to check, because undefined behavior may lead to interesting effects on the runtime, because you never know what you actually get in the end. So undefined behavior sanitizer can catch these kind of things and can suggest you that you probably need to fix that. Data flow sanitizer is not actually a real sanitizer. It's more like an API, so you can implement some checks based on this API. It's still a work in progress, available only on 64-bit Linux. There is some coverage callback also and the things like that. Okay, so that was about the dynamic code analysis and code analysis in general. Talking about refactoring stuff. I'm not going to talk about it a lot, but I would like just to say that Talking about refactoring, so there is like a basic set that's just rename, inline, or extract function, and there is more profound set that the tool can do for you, like this kind of change signature and move methods through the hierarchy. But what's important here is that the requirements for the code refactoring is sometimes really tough, because you not only have the tricky C++ that you have to parse correctly to like actually refactor it correctly, you have to distinguish C and C++ to make a proper code in the end, and also you have actually to update the whole project, not just one translation unit while refactoring, because otherwise you get an incorrect code in the end. And that's not talking about the non-code usages and all the stuff like that. So there is the Clang family tool called Clang-rename, which I want to mention here, but I have to say that it's actually not fulfilling all the requirements, because it's just a rename inside one translation unit still. But we might get more, and at least like Xcode doing some job on Apple's side and implementing some refactoring based on Clang, we'll see. And there are actually many tools that have refactorings. And there is a very nice tool that actually checked, that's called the refactoring test suite. So there is a guy called Richard Thompson who implemented it. And he actually put some very nice test suites covering from the like old style to the modern C++. And he implemented this kind of checks, and he runs, he ran this test suite for various tools. He checked CLion, Clang Modernize, that is Clang Tidy Modernize, ReSharper for C++, Visual Assist, and Visual Studio 2015. And he has actually some more plans on his GitHub page, what tools he actually would like to check as well. The good thing is that he not only checked the tools, but he provided the full list of results, so you can see actually which cases the tools are like passing or failing. So just in case you're interested in how the refactoring may work and which problems they may like solve, or which tricky cases they might not overcome, you can look at it and check. Okay, so if we refactor the code, that would be actually good to check that we haven't actually broken anything, and that's what we have the unit testing for. In the beginning of the 2017, we did kind of a survey about the ecosystem for various languages, and there was a part of for C and C++, and we got some results about usages of the unit testing framework. So you might not expect or not, but the Google tests are still one of the most popular. Then comes the Boost test, and then all the rest. That's an interesting story, actually, that we have the Google test dominating the market that much, but it's kind of interesting because the Google test is not that easy to actually include to your project, because they're not header-only, like, for example, Cache framework. That is a header-only framework. You just include a header and you get everything on board. With the Google test, it's recommended to grab the whole repository and to actually compile it with your project to avoid some kind of problems with the inconsistent compilation flags and all the rest. So you have to download the code, you have to include it into a project, and then you can start using the Google test. And Boost tests, they are available, the framework is available in both ways, so you can either include as a header or you can compile with the whole Boost test, but actually header is not recommended for the heavily templated code because it's increasing the build times for your project. And that might be it, but that's not. I have one bonus points here, and that's for sure the package managers. So talking about the code quality nowadays quite often covers this story, and I'm very happy because that's a story that's very interesting for C++. You know what's the biggest problem for C++ with package managers? We didn't have them for many years. And now we're starting getting more on this fault, and that's good. And if we try to understand why do we have such problems, the answer is quite obvious, actually, because we have the one definition rule first. So we have, if we have different compiler flags and compiler versions for library and for my code, we might run into a situation when we have some kind of runtime issues. So in that case, what's our typical way of C++ programmer to add a library to my application? We need to find the sources somewhere first. That could be tricky on its own, but still, happily, we have a GitHub. We found the library there. We want to use it. What's next? We need to find a way how to build it. Quite often, we're spending half of the day trying to understand how to build the library, because there could be some instructions provided, but maybe they're not full, maybe they're just for one platform, maybe they are outdated. Anything could happen. When you successfully build a library, you now have the second step. You now have to include this library into your project. But with C++, when we have that many different build systems available for our projects, that might be tricky because the library might be built with another build system. And it's good now when there are like CMake projects and some library providers, they provide, even if they are not building their library with a CMake, they can provide a CMake file that you can include and build the whole stuff with a CMake. But still, sometimes it's a very tricky process. So yeah, and the third point here is the variety of the build system that I talked already. And the build system actually can be divided in different groups. So they could be language level, they could be external, they could be build system agnostic or just built into your build system. They can be source-based, or they can use the pre-built binary, or they can use the combined way. And they can be system or language specific. And if we take a couple of examples of the tools from different categories here, and to see what we actually have for C++, you'll be surprised, but a year ago we had a proposal for develop package manager system built into the actual C++ language. There was a proposal from Blizzard, and you can find it by this number. And so it was building this kind of couple of keywords into the language, and there was some implementation started for Clang in the first repository. Then there was a fork where another guy proceeded in the second repository, but everything actually died, so the repository is not that active. And I think the biggest problem is that C++ incorporates that many things into the language that I don't think we need a package manager into the language. Because it will be just a nightmare to deal with a language that has that many things on board. But at least it was kind of an interesting experience, so we can check it to see how it might be. There is this kind of tools that are built into some particular build systems, like for example Hunter, that is CMake based. It is actually very nice. There is this kind of a Hunter Gate meta package with different URLs that you can configure. There is support for famous packages that you might want to have on your project, like famous libraries. And it supports many platforms. But I think that this one is maybe better choice because it's independent on the build system. It's Conan that has actually, it supports any build system, and it has predefined helpers for CMake if you're a CMake fan. It supports different languages, different platforms, and it actually has lots of packages available. And so it's actually good, and it has this nice touch of Conan profile that allows you to use different configurations on your local machine at a time, and it can use the pre-built binaries or built from sources if the proper pre-built binaries is not available. It's checking it for you. So these are kind of a free tools that represents this group from the table, and so we have more that is system independent, that is dependent on the language. But currently the Conan is probably the most active one, and after acquiring by JFrog, they are built into the Refactoring tool, so you have the full support there, and that's actually good for C++. And that's mostly it about the tools. I have a couple of references here if you want to read more about some things I was mentioning here, like the ecosystem survey or this kind of a refactoring test suite or some other references. And so if you have any kind of questions, I can handle them. We have a couple of minutes. Okay, any questions here?
Thank you. I was kind of interested, you said you started with an example of people leaving and code being aggressively rebuilt. I was sort of contrasting that with the way that cloud code-based people think about microservices these days in terms of code. Good code is small enough and encapsulated enough that you can throw it away and rewrite it when the time comes. And I'm wondering how that kind of thinking about code kind of meshes with your experience of C++, which is a different ecosystem.
Actually, like, my experience was mostly with that particular example. The problem was that the code was very complicated. And that's the thing that you can achieve quite easily with C++. You're just writing very complicated code that no one in the team could actually read and support. And then you just have to throw it away, because either you spend 2 hours trying to understand what's happening there, or you just throw away and implement it from scratch during 1 hour. But that's a bad code, because throwing code away each iteration is not good. There was some kind of investigation about how long the code usually lives, and there are some numbers like something around 6 years. But at least for these 6 years, you have to maintain and support the code, not throwing anything away. And so these 6 years, you have to get some kind of a code with a good quality, at least to support it for this period of time.
Okay. One really quick question.
Yeah.
Does TeamCity have any support for these static analysis tools?
There are some tools at TeamCity that you can use for static analysis for some particular languages. So you can come to the booth and we'll discuss it in more details, not to distract the whole audience with our tools.
Okay, then join me in thanking Anastasia again.
Thank you.
And the next session in here will be